I see a higher ALPHA value as increasing the strength of regularization. This means I'm penalizing complex models more heavily, forcing the model to become simpler and less prone to overfitting. Think of it like adding a penalty to making the model too complicated. A smaller GAMMA value leads to a wider kernel in the radial basis function, RBF. A wider kernel makes the model less sensitive to individual data points, resulting in a smoother, less wiggly model that generalizes better. It's like using a broader brush to paint the data. The details become less important, focusing on the overall trends. I'm tackling the challenge of preventing overfitting in a KernelRidge model. Overfitting happens when a model learns the training data too well, including the noise, and doesn't generalize well to new data. We'll explore how to adjust hyperparameters to address this. I'll explain how adjusting the hyperparameters, alpha and gamma, impacts the model's performance and helps prevent overfitting. Alpha controls the strength of regularization, which is a technique to prevent overfitting. A higher alpha value means stronger regularization, making the model simpler and less prone to overfitting. A lower alpha value means weaker regularization, allowing more complex models, which makes overfitting more likely. It's like adding a penalty for model complexity. Gamma is a parameter specific to certain kernels like the radial basis function, RBF, kernel. It determines how wide the influence of each data point is. A larger gamma creates a narrower influence, making the model very sensitive to individual data points, leading to overfitting. A smaller gamma leads to a broader influence and a smoother model that is less sensitive to noise, reducing overfitting. Think of it as controlling the model's sensitivity to individual data points. I'm tackling the challenge of overfitting in KernelRidge regression. To fix this, I'll focus on two key strategies: increasing the regularization strength, alpha, and decreasing the kernel's sensitivity to individual data points, gamma. These adjustments make the model less complex and more robust to noise. I'll boost the alpha hyperparameter. A larger alpha value increases the strength of L2 regularization, forcing the model to have smaller weights. This simplifies the model and prevents it from learning the noise in the training data, thereby reducing overfitting. It's like adding a penalty for overly complex solutions. I'll reduce the gamma hyperparameter. A smaller gamma value widens the radial basis function, RBF, kernel. This makes the model less sensitive to minor variations in the data, smoothing out the decision boundary. The model becomes less prone to overfitting to specific data points. Think of it as blurring the details to focus on the bigger picture. I'm using KernelRidge regression from Sklearn to model a relationship where data points are not linearly separable. Unfortunately, my model's learning too much about the training data including noise, so it doesn't perform well with new data. This is overfitting. I'm focusing on fixing overfitting in my KernelRidge regression model. My goal is to improve its performance on new, unseen data by finding methods to adjust the model's complexity. This title tells us the quiz focuses on how to fix a common machine learning problem: overfitting. Overfitting happens when your model learns the training data too well, including its noise, and doesn't generalize to new data. The quiz will assess my understanding of techniques for KernelRidge, a specific regression model in Sklearn, to deal with this issue. This is the core problem. We're using KernelRidge, a powerful tool, but it's not performing as expected because it's overfitting. I need to identify techniques that improve performance on unseen data, meaning reducing overfitting. This option deals with alpha, the regularization parameter in KernelRidge. I need to know that increasing alpha increases regularization strength, which reduces model complexity and thus combats overfitting. Here, we're doing the opposite of option A. Decreasing alpha weakens regularization, making the model more complex, thus more likely to overfit. This option focuses on gamma which determines the width of the radial basis function kernel. A higher gamma means a narrower kernel, making the model more sensitive to individual data points and more likely to overfit. In contrast to option C, a lower gamma creates a wider kernel, leading to a smoother model that's less sensitive to individual points and is therefore less prone to overfitting. Overfitting happens when a model learns the training data too well, including the noise, and doesn't generalize well to new, unseen data. To avoid this, we need strategies that simplify the model and improve its ability to predict accurately on new data. This involves careful tuning of hyperparameters. KernelRidge is a regression algorithm in Sklearn that uses kernel methods to model nonlinear relationships. It's like a fancy curve fitting technique that can handle more complex data than simple linear regression. A key aspect is how we control its complexity to prevent overfitting. The key hyperparameters we'll focus on are alpha and gamma. Alpha controls the strength of regularization. Think of it like a penalty for overly complex models. Gamma, in the case of an RBF kernel, a common type of kernel, controls the smoothness of the model. This question asks you to identify methods to reduce overfitting in a KernelRidge model. The question presents options involving the hyperparameters alpha and gamma, testing your understanding of how they affect model complexity. Increasing alpha makes the model simpler, directly combating overfitting by reducing model complexity. It's like putting a brake on the model's ability to memorize the training data. Increasing gamma makes the model too sensitive to individual data points, leading to overfitting. Think of it as making the model too focused on the fine details, losing sight of the bigger picture. Decreasing alpha makes the model more complex, increasing the risk of overfitting. It's like giving the model more freedom to memorize the training data, potentially failing to generalize to new data. Decreasing gamma creates a smoother model, less sensitive to noise, directly mitigating overfitting. Think of it as smoothing out the model, ignoring minor details. This is the overall topic: how to deal with overfitting in KernelRidge regression models, a common machine learning problem. We'll explore ways to make the model more generalizable. We're tackling a common machine learning problem: overfitting. This happens when our model learns the training data too well, including its noise, and fails to generalize to new, unseen data. In this case, we're using Sklearn's KernelRidge regressor, a powerful tool for nonlinear regression. We need to find ways to improve its ability to make accurate predictions on data it hasn't seen before. This question asks you to identify the best strategies to improve the KernelRidge regressor's performance by reducing overfitting. Think of it like this: you are trying to teach a child to ride a bicycle. If you focus too much on tiny details, the child might not learn the general skill of riding but get lost in perfecting tiny aspects. The same goes for our model. Overfitting means that it's overlearning the details instead of the big picture. Alpha is the regularization parameter in KernelRidge. Increasing alpha adds more regularization. Think of regularization as adding a penalty for complexity. A higher penalty discourages the model from fitting the noise in the training data, leading to better generalization on unseen data. I'd say this is one step closer to our goal. Gamma is a parameter for the radial basis function, RBF, kernel, which influences how wide each data point's influence is. A larger gamma means a narrower influence, making the model sensitive to slight changes. A smaller gamma broadens this influence, smoothing the model and reducing its sensitivity to noise. So, decreasing gamma helps avoid that overlearning and focuses on broader patterns. I would choose this too.